In this short video, I'm going to discuss the Squeeze theorem. It's also known as the sandwich theorem. Now, when a theorem has its own name, that is an indication that this theorem is important. And we are going to use this theorem not only in Calculus 1, but in other calculus classes as well. We're going to use the following fact. And it makes sense that if you have two functions, f and g, and the limit as x approaches a of f of x exists, and the limit as x approaches a of g of x exists, and you have f of x always being smaller than or equal to g of x whenever you're close to a, then it makes sense that in the limit as x approaches a of f of x is going to be less than or equal to the limit as x approaches a g of x. Graphically, that just says that if the graph of f lies below the graph of g whenever you're close to the number a, then in the limit as x approaches a, the graph is still going to be below it. Now, just as a reminder, neither f of a nor g of a need exist, and that's why I put a little circle here to show that in this case g of a does not exist, but the limit as x approaches a of g of a does exist. So here's the statement of the Squeeze theorem. We're going to build this sandwich of functions. G of x is going to be the meat in the middle. F of x is the lower bun. H of x is the upper bun. And so if g of x is squeezed between f of x and h of x, and both f of x and h of x tend towards the number L as x approaches a, then the limit as x approaches a of g of x must also be L. So graphically, what do we have here? G of x is being squeezed between h of x and f of x as x approaches a. And they're all going to converge on the y value, L. Well, let's see an example where we need to use that. We're asked to show that the limit as x approaches 0 of x to the power of 4 sine of pi over x, that limit is going to be equal to 0. Now you might say to yourself, oh, well, that's obvious. If I just put 0 in for x, then x to the power of 4 is 0. Well, I can't do that. X is not in the domain of this function. I can't have pi over 0. That's not defined. In fact, then I couldn't even use the limit laws because the limit as x approaches 0 of sine of pi over x does not exist. However, I can start to build a little sandwich here because I know that a property of the sine function is that whenever it's defined, so when x is not equal to 0, its value has got to be between -1 and +1. Another thing that's important about this function is that I'm multiplying by x to the power of 4, an even exponent, and so x to the power of 4 is always positive. Now, both those statements are important. Of course, our first statement is going to allow us to start to build our function sandwich, and we're going to have the x to the 4th sine of pi over x in the middle. And number 2 is important because we're going to start with our first statement, and we'd like to multiply that by x to the power of 4 to get our target function in the middle. But I have to remember that if I multiply an inequality by a negative number, we have to reverse the inequality sign. Well, we don't want that to be reversed. We want to keep these inequality signs as they are, at least whenever x is close to 0. And so we're always going to have a positive number. So if I put those two together, I can multiply my initial sandwich by x to the power of 4. Then when I multiply that, remember that I have to distribute this multiplication to all three parts of this inequality. And after I do that, I'll have negative x to the power of 4 is less than or equal to x to the power of 4 times sine of pi over x, which is less than or equal to x to the power of 4. So now I've got my function sandwich. G is in the middle, I've got f underneath and h on top. The only thing that's left is for me to write the conclusion of this statement. And how do I write that? And pay attention here, this is important. We want to make sure that we're using good mathematical language with proper English. So I start off by saying, okay, since negative x to the power of 4 is less than or equal to x to the power of 4 times sine of pi over x is less than or equal to x to the power of 4, and since the limit as x approaches 0, negative x to the power of 4 is the same as the limit as x approaches 0, x to the power of 4, both of those equal 0, then by the squeeze theorem, the limit as x approaches 0 of x to the power of 4 sine of pi over x must also equal 0. So we have to state all of the work that shows how we get to our function sandwich, and then state that we have that sandwich, and we know what the limit values are of the outer functions, and then we have to say by the squeeze theorem. We need those 4 words. By the squeeze theorem, the limit of the middle is going to be the same as the limit of the outer functions. I hope you found this short video on the squeeze theorem useful.